Determine whether the graphs of the following set are parallel, perpendicular, or neither. What we'll need to do for both of these equations is to solve them or rearrange them so that they are in slope-intercept form. In other words, to solve for y. So we'll do that for both equations. Now, if the equations have identical slope, then the equations would be parallel. If the equations have reciprocal slopes, then they would be perpendicular. Or if neither of those parameters are met, then the answer would be neither for these. So let's go ahead and solve. We'll start out with 3x plus 5y equals 10. First thing we'll do is move this 3x over. And we'll do that by subtracting the 3x on the other side. In effect, eliminating 3x on the left. And so now the equation looks like 5y equals negative 3x plus 10. Okay, and if you're confused by the arrangement, all I did was move the negative 3x into the front and back up the 10, as that's the order that traditionally is set for equations. We put the variable terms in front. All right, and now what we're going to do is divide out the y. So we will divide the negative 3x term and the constant of 10 by 5, in effect isolating y. And so we get a slope of negative 3/5 here, as that is the coefficient of x, and 10 divided by 5 is 2. So here's our equation. That first equation has been solved for y, and it is slope-intercept form. Now we'll have to do the same for the second equation. Let's make some space here for that. Okay, so we have 5x minus 3y equals negative 6. So once again, we'll eliminate this 5x. And we'll do that by subtracting 5x on the other side. Leaves us with negative 3y equals negative 5x minus 6. We'll divide out that coefficient of negative 3 so that we can isolate y. So we have negative 3, negative 3. So we have y equals, so notice that we have negative divided by a negative. That's going to leave us with a positive coefficient of x. It's going to be 5/3 x, and negative 6 divided by negative 3 gives us a positive 2. All right, so let's make some space for our reordered equation, and then we can compare it to its counterpart. So we just got y equals 5/3 x plus 2. And so we want to inspect the slope of each equation. And what we have, indeed, we do have negative reciprocals. And I think I may have failed to mention that. I think I said reciprocal slope would indicate that the lines are perpendicular, but it is negative reciprocals. And you can see the first equation has a slope of negative 3/5, and the second equation has a slope of 5/3, which in fact is a negative reciprocal. In other words, it's a reciprocal of the value of the other fraction, and it is also the opposite sign, okay? And so since the negative reciprocal parameter is met, then we do have a solution of perpendicular equations.